Finding the sample size required to estimate a population mean. Objective: determine the sample size n required to estimate the value of the population mean. The notation: mu represents the population mean, sigma represents the population standard deviation, x bar represents the sample mean, capital E represents the margin of error, and z subscript alpha divided by 2 is the critical value, the z-score separating an area of alpha divided by 2 in the right tail of the standard normal distribution. The requirements: the sample must be a simple random sample, and the required sample size is found by the following: n is equal to the critical z value times the population standard deviation divided by the margin of error squared. Now, the round-off rule for determining sample size: if the computed sample size n is not a whole number, you round the value of n up to the next larger whole number. Dealing with unknown population standard deviation when finding sample size. Number 1. The range rule of thumb. You use the range rule of thumb to estimate the standard deviation as follows. Population standard deviation is approximately the range divided by 4, where the range is determined from sample data. Number 2. Start and improve. You start the sample collection process with knowing the population standard deviation and using the first several values. You calculate the sample standard deviation S and use it in place of the population standard deviation. The estimated value of the population standard deviation can then be improved as more sample data are obtained, and the sample size can be refined accordingly. Number 3, you estimate, use prior results. Estimate the value of the population standard deviation by using the results of some other earlier study. In addition, we can sometimes be creative in our use of other known results. Using a value for the population standard deviation that is larger than the true value will make the sample size larger than necessary, but using a value for the sample standard deviation that is too small will result in a sample size that is inadequate. So when determining the sample size n, any errors should always be conservative in the sense that they may make the sample size too large instead of too small.